we are going to continue to add details to what we're learning about all of these polynomial functions. We've talked about how to find zeros. We've talked about the overall shape or end behavior of our graph. And so far, when we had zeros and we predicted the shape, we just picked some x values in between the zeros, right? And we calculated a y value to kind of see how high we had to get. And we calculated how low we had to go for that turn. But we were just picking a couple numbers just to get an estimate. Today we're going to start actually finding those exact turns. Okay? They're called turning points. They're also referred to as relative maximums and minimums. What you're going to do is look for places on your graph where there is a turn. In other words, instead of moving down, we start moving up. Okay? That's a turning point. Instead of moving up here, we're moving down. Another turning point. They're called relative max and mins because they're not an absolute maximum or minimum. Your graph, based on these arrows, keeps getting higher on the left and lower on the right. There is no end to it. So there's no absolute maximum it's going to get to or a minimum it's going to get to. But within the middle of our graph, where we're really worried about all the turns it's making, we have those relative max and mins. So we're basically going to have to tell our calculator, in this little part of my graph, what's its highest point or its lowest point? Okay? To do that, you have to set bounds. What we're going to see on our calculator, if we are trying to find this relative maximum, we are going to have to tell the calculator, look between these two cutoffs and tell me where it gets the highest. Okay? This is called a left bound. It's to the left of your high point. This is called a right bound, to the right of your high point. We're going to do the same thing for our minimums. We're going to set those boundaries. There is no exact location you have to put it at, but your left bound has to be to the left of your turn, and your right bound has to be to the right of the turn. And you have to set the left bound first. It's going to ask for that, so you have to lock that one in first. You don't want your boundaries to be too far away because it just takes the calculator longer to find that max or min. Right? It has more to look through. Okay? So what we are going to do, we're going to type this in our y equals on our calculator, and then we'll start looking at what the graph is going to look like. So in your y equals screen on your calculator, your variable key is right here. All right, so we have x. Our power key is over here. We're going to use a third power. And on a lot of the newer calculators, you have to arrow out of that exponent position and get back down to continue. Okay? Our next piece is plus 3x squared. And then we have a minus 24x. And just be careful, your calculator is very picky about minus signs versus negative signs. You wouldn't want to hit negative 24x because then it's going to say the 3x squared and the negative 24x are being multiplied together. Okay? You want to make it subtraction. All right, questions at all on getting it entered? I did have to do it. It just doesn't show up on mine. So anything higher than a 2, you've got your x squared key over here on the left, but anything higher, you're going to be using that caret key, that upside down V looking thing. Okay? All right, we want to graph this. I always start with a standard graph of negative 10 to positive 10, both for x and y, and then if I have to make it bigger in one direction or another, I can. The fastest way to set that standard window is to do a zoom 6. So hit the zoom key, number 6, it says Z standard. We're going to start out just looking at that part of it. Is my X window big enough? Well, let's think about the shape of our graph. It was an X cubed, right? Do we see a cubic twist in this window? my graph is never going to come back and cross again, right? Then it wouldn't be cubic. So I know that I don't have to make my x window any bigger, but I am not seeing my high and low points. Okay? So I do want to make my y direction bigger. So we're going to go back to window here, and we're going to change our y min and max. Let's make the minimum, let's say negative 30, and our maximum, let's look at positive 30. I'm going to go down here to the y scale and change that to a 0, because otherwise it's trying to put 60 tick marks in there, and it's just going to make it look like a solid line on the y-axis. Okay? Let's look at our graph. So, is it low enough? Am I seeing the low turn, the minimum? Yes. Am I seeing the maximum? So I'm going to make it get a little higher. I'm going to go back to my window, and let's set our y max. Let's put it up at 100. All right, and now we can see the nice cubic graph. Okay? To find our minimums and maximums, we are going to hit the second key and then this trace key. Notice up at the top of it, it says calc. We are calculating some things. We're calculating a relative minimum and a relative maximum. Notice also in this menu that we could calculate a 0 or an x-intercept. We would only use that feature if our zeros were coming out as some weird decimal numbers. But if we get nice integer values or fractions for zeros, we should be able to solve it, factoring, that kind of thing. Okay? So, doesn't matter. Let's do the minimum first. I'm going to press number 3 to select minimum. And now, do you see your cursors blinking? You are going to use your left and right arrows to move that cursor. I need to move it to the right. And I'm going to lock in a spot where my cursor is like right now. I'm to the left of my turn. Notice at the bottom of your little screen it says left bound. It's waiting for you to lock in that left side. Okay? So I'm going to hit enter to lock it in. And do you see that there's a little arrow up at the top? That's where it's locked to that position, okay, for that x value. Now I'm going to use my right arrow again, and I'm going to move around past the turn, past that minimum point, and I'm going to lock in my right bound. So I hit enter. Now I've locked in the two sides, and it's asking me to make a guess. You don't have to do that. You can hit enter again, and the calculator is going to look between those two marks and say where within this little window is it lowest. All right? Look at the coordinates at the bottom of your screen. It says our minimum is 1.9999999. So 2, right? That would be a 2. And our y value is negative 28. So our lowest point, we're going to say we have a relative minimum at 2, negative 28. Okay? Now we're going to do the same thing over again to find our maximum. So we're going to go back to our calculator. I'm going to do a second trace again. And this time I'm going to choose number 4, a maximum. It's real common for students to want to stop right about here and lock it in. But remember, you got to lock the left side before you lock the right side. So we are going to have to continue past that turn, lock in our left bound, and now go back around using our right arrow, lock in the right side, and hit enter again to bypass our guessing. So we're getting a relative maximum of negative 4 and 80. All right, are we having any issues with the calculators? How to find that? Anybody? If you get decimal numbers, I would say go out to 2 decimals to the hundredths place. All right, that's far enough. You can round to those. Okay. For our next one here, I'm going to have you enter this in your calculator, this new equation. And if you are on the left side of the room, I'm going to have you guys find the minimum, the relative minimum. And if you're over here, I'm going to have you find the relative maximum. Okay? I'm going to pause the recording and give you time to do that. All right, so what did you end up with for? Let's do the relative minimum first. What did we get for minimum? 0.64. -2. Okay. And a relative maximum? Negative. Okay. 3.13. All right. Agree, disagree? Okay. We're going to look at an example of where we might use our calculator to help us with this. It says the design of a digital box camera maximizes the volume while keeping the sum of the dimensions at 6 inches. If the length must be 1.5 times the height, what should each dimension be? Lots of things to break down here. First thing I think of is I've got a box, right? They're saying this camera looks like a box. Okay? What do I know I'm trying to find? I need to find all the dimensions, right? So can we think of this as length, width, and height? Okay. They're asking me to make sure I maximize the volume. So I want to figure out dimensions that are going to get me the biggest volume. How do we find volume for a box? Good. Length times width times height. So let's label what we can on our picture here. They are telling me that the length has to be 1.5 times the height. So whatever dimension I use here, let's say I use an x for the height, my length has to be 1.5 times that. Yes? All right. So I need 1.5 x's for a length. I need a single x for height. The only thing they gave me to help me figure out the width of this is that the sum of my dimensions has to be a 6. Well, how much of those 6 inches have I already used up? I used an x, right? I used x inches for the height, and I used 1.5 x inches for the length. So I've used up 2.5 x's. Does that make sense? So of my 6 inches, I have to take away the 2.5 x that I've already used up. That would be what I have left over for that third dimension. Okay? Questions on that? You told me earlier volume is length times width times height, so I have to multiply these three expressions together. X times 1.5 x times 6 minus 2.5 x. All right, x times 1.5 x would be 1.5 x squared. And then if I distribute that, 1.5 x squared times 6 would be 9x squared. And 1.5 x squared times a negative 2.5 x ends up being negative 3.75 x to the third. I'm going to rearrange that, put it in standard form. So my cubic term is going to go first. And I'm doing that to help me picture what this graph is going to look like. We have a negative x cubed. So it's going to have that cubic twist to it, but it's going to be reflected over the x-axis, right, upside down. So we should expect to see some kind of picture like this. We good with that? Okay. Go to your calculators and type that in. Negative 3.75 x to the third plus 9x squared. Again, I'm going to do a zoom 6, restart my window at its normal size. Do I see enough of my graph? Yes. They are asking me to maximize the volume. And the way we've graphed this would be height, right? Our x-coordinate was our height, and our y-coordinate was the volume. Can the height of my box be negative? Can the volume of my box be negative? Then I don't need anything but quadrant 1. I'm just needing to look in quadrant 1 and say, where will I have the maximum volume? That means I have to find this point right here, right? That's in quadrant 1 where it's going to be its highest. So let's grab our calculators. We're going to do second trace. We're going to find a maximum. We're going to set our left bound and our right bound. You should be getting something very similar. Now I've done this 3 times today. The other 2 times my x value was 1.6. Now it decided to be a little more exact, 1.5999. Okay? So we would round that to 1.6. And our x, we said, was the height of my box, correct? So I would put over here that the height of the box is going to be 1.6 inches. The length of the box, we said, was 1.5 times that. So 1.5 times 1.6 comes out to be what? Okay, so 2.4 inches, and then the width. Now, you can either put a 1.6 in here for x, or you can say they have to add up to 6, right? My 3 dimensions have to add up to 6. How much have I already used? I've used 4, so I have 2 inches left for that third side. And if I use those dimensions, I will get a maximum volume of 7.68 cubic inches. Okay? My y-coordinate from my maximum point. Questions on that? All right. We are going to jump a little bit out of order here. There's a piece of section 5.5 that makes more sense to talk about with what we're doing here. When we find our zeros, the last couple days, our zeros have been nice integer values, right? 5, -2, 3, things like that. We can have zeros that don't come out that nice. Whenever we have an irrational zero, we have to make sure that it occurs as a pair. Okay? The same happens with imaginary or complex zeros. We've talked about conjugates in the past. If a plus bi is one of my zeros, then a minus bi has to be one of my zeros. They have to occur as conjugate pairs. Now, that doesn't mean if 5 is a 0, then -5 has to be. Those are not complex numbers. Okay? That's just a nice real integer value. Okay? But for complex ones where we've got that imaginary piece to it, they have to occur in pairs. The same is true with zeros that are irrational. So when I get things like square root of 2, if that was one of my zeros, then its conjugate has to be in there as well. So what is the conjugate of a plus the square root of b? We would need a minus the square root of b. Okay, that also has to be one of my zeros. So irrational numbers would be things that have those square roots in them. Okay, complex numbers are the ones that have the real and imaginary part to them. So things like 2 minus 3i. Okay? If you see either of those types of zeros, then we know its pair has to be in there. And that's what this conjugate root theorem says. Okay? That if a plus the square root of b is one of my zeros, then a minus the square root of b has to be 1. And if a plus bi is a 0, then a minus bi has to be 1 as well. Yesterday I mentioned to pay attention to the type of polynomial they're asking you to come up with. In this case, they're asking me to find a quartic one. Well, what is that degree? Degree 4. If it's a degree 4 polynomial, it has to have 4 zeros. They don't all have to be real. They don't have to be nice integer values, but there has to be 4 of them. Okay? They're telling me that the square root of 2 is one of my zeros. They're also telling me that 1 plus I is one of my zeros. But that's only 2 of them, and we said we had to have 4. This one, the square root of 2, is irrational. It can't be written as a nice rational number, as a fraction. Right? It's a non-repeating, non-terminating decimal. Because of that, I know that its conjugate has to be in there as well. Now I've got 3 of my 4. What's the 4th one? If one of my zeros is 1 plus I, then I have to have 1 minus I. Okay? Looking at this one. How many zeros are they telling me I'm going to need? 3. How do I know that? It says it's cubic. A cubic polynomial's got to have 3 zeros. How many did they give me? I see 2. That means there's 1 that's missing. What's the missing one? Yes, we have a complex 0 here, 3 minus 2i. So its conjugate, 3 plus 2i, has to be in there as well. Now, a lot of students see this 5 halves and they think, oh, I need a negative 5 halves. No, 5 halves is not irrational. That is a rational number. Those don't have to occur in pairs. If I said a 0 is at 3, it doesn't have to have a negative 3. Okay? It's just the complex, the imaginary ones, and the irrational ones, the square root ones. All right, so our last 2 questions. We are going to do what process we started yesterday, where if I give you the zeros, can you write the factors and then build the polynomial from it? Okay? So I just put a little refresher up here. If I have a 0 at 5, its factor is going to be x minus 5. Yes? The factor is always going to be x minus whatever your 0 is. Okay? So if I have a 0 at negative 2, my factor would have to be x plus 2. And then once we have the factors all laid out, we can multiply them together to get our polynomial. All right, we got 2 of these to do. Ignore the multiple choice part of this here. It just says, what is a 3rd degree polynomial? Same as saying a cubic, okay? So there's 3 zeros. They're telling me that the 2 zeros we know about are negative 4 and 2i. What is my missing one? Good, negative 2i. So I've got my 3 zeros now accounted for. what are the factors going to be? What would the factor be for a negative 4, 0? Yep, x minus negative 4 would be x plus 4. Then we need x minus 2i. Then we need x minus a negative 2i, which would be x plus 2i. You can save yourself a lot of headache if you put the conjugates together first. Because what happens when you multiply conjugates? The middle stuff drops out, right? Of that foiling process, insides and outsides are going to drop out. So let's go ahead and FOIL together the x minus 2i and the x plus 2i. What do we end up with? X times x. X squared. Insides and outsides we said would drop out. Last term, negative 2i times a positive 2i gives us negative 4i squared. But in our last chapter, we learned what that was. What is an I squared? It's a negative 1. So this really is saying that we're taking negative 4 times negative 1, which would really be a positive 4. All right, now we can FOIL that together. What do we end up with? X times x squared would be x cubed. Outsides we get 4x and insides we get 4x squared. I'm going to put the 4x squared first so it's in standard form, and then the 4x. And then the last term would be a 16. Okay? That is the polynomial that has those 3 zeros. Now, if this were a test question and I had a little extra time, I would type that in my calculator because I can check that it's going to hit the x-axis at negative 4, right? That's a 0, an x-intercept. If I put this polynomial in and it's not crossing at negative 4, I know I made a mistake somewhere. I will not see those imaginary zeros. They're imaginary. They're not going to show up on a real coordinate plane. Okay? But you can at least check the real ones and make sure that it's working out right. All right, last one. What quartic polynomial equation has roots of negative 3i, 8, and 2? How many zeros should we end up with? 4. How many did they give me? 3. That means I'm missing one. What's the one I'm missing? Okay, so I'm going to go ahead and put the 3i next to the negative 3i so that when I multiply those conjugates together, they're back to back. Okay? My factors would be what? Okay, x plus 3i. Next one, x minus 3i. And then x minus 8 and x minus 2. Okay? Now this one gets a little more involved, but again, put your conjugates together. So x plus 3i and x minus 3i turns into what? X squared minus 9i squared, which really means x squared plus 9. Okay, let's FOIL these two together. What do we get? X times x. How about insides and outsides? What are they going to get us? Negative 10x for a total. And last, 16. Okay. We did one like this yesterday. We have to distribute the x squared to each of those, and then we have to go back and distribute the 9 to each one. Okay? X squared times x squared is x to the 4th. X squared times negative 10x would be negative 10x cubed. X squared times 16 is 16x squared. Then I'm going to go through and distribute the 9. So 9 times x squared, 9 times negative 10x, and 9 times 16. And the only like terms I have are right in the middle, the 16x squared and the 9x squared. So final answer, x to the 4th minus 10x cubed plus 25x squared minus 90x plus 144. Okay? Quick check. We said if the square root of 2 was a 0, we also had to have a negative square root of 2. So my factors would look like this. Yes? And if you multiply those together, what are you going to get? X squared. Will the insides and outsides still drop out? Yes. My last term becomes a negative root 2 times a positive root 2, which would be a negative root 4, but the square root of 4 is 2. So this really becomes x squared minus 2. Does that make sense? Okay. All right, so for homework, it is on 2 separate pages because remember I said we threw a little bit from 5.5 in there? So this first stuff here, you are working on finding max and mins with your calculator. Okay, just practicing that skill. I'm going to have you look at 55, 58. I do want you to try 56. See what you can come up with for 56. And then in section 5.5, page 316, you're going to do 18 to 25. And I want you to give these a try as well, the 39 to 41. Okay?